All right, so we're brainstorming things that we're thankful for this year because Thanksgiving is in 2 days. So we're thankful for the knowledge I obtained in CS 490. That's okay, whatever, suck up. Um, we're managing to get married despite COVID. That's cool. Not failing anything, trying new things, not having to commute to campus. Yo, real talk though, for like not having to commute has saved me so much time. Last semester for 435, I was living in Manhattan, and my commute was about an hour each way on good days. So like an hour each way was just a pain in the ass. Like it would be a 2 hour commute just to teach my classes, and then on top of that, you have like office hours and everything like that. This semester, I just feel like I have so much better work-life balance just because I don't have 10 hours of commuting in any given week. So very, very thankful for that. I am very thankful for classes coming to an end too. I think this semester has been one of the most stressful semesters I've had. I'd say this was the second most stressful semester I have had either in undergrad or in like the teaching side of things. So yeah, this has been a tough semester. Good job hanging in with me, but it's nice that everyone has found things that they are thankful for this year. I yeah, I have definitely some things that I do have. The second most, yeah. I had one semester where the Boston bombings happened at MIT while I was at MIT, and that was, I'd say, a lot worse than COVID. That was horribly stressful. Just like literally having a terrorist attack on campus, very close to me. So this was a second place winner. This gets the silver medal in terms of terrible semesters, but this isn't great either, as you can imagine. Cool. Let's jump into our lecture today. So the first 15 minutes ish of lecture today. Oh yeah, I'm also thankful for having a working iPad. So our lectures are probably going to be on iPads now because I'm more of a iPad person and a whiteboarding person than I am like a slides person. So I'm very thankful for having an iPad working again. So that's my nerdy little teacher thing that I'm thankful for. Cool. So today we're going to be talking about more software design. That's going to be the theme of a lot of our lectures going forward. How to design software, how to make it scalable, stuff like that. Couple administrative notes. Make sure you're keeping up with your homework. If you fall behind, you can still do it for full credit. All of the homework due dates are still made up. So if you haven't turned in homework 5 right now, go ahead and do homework 5. I just made up all of those to keep you on track, but you can do them whenever you want. That's not true for your projects and that's not true for your exams. So like anything project 3 related, so that's like peer feedback, individual feedback, MVP submission, all of those stuff are real deadlines and you get an automatic 0 if you don't do it on time. We're not going to like chase you around. We're not going to ask if you can redo it. You just get a 0 automatically. You have 2 extra assignments for the project 3 MVP, and I'm sorry about that. I'll explain why in a second. The individual assignment is basically rated feedback about your peers. The reason we're doing this is it was very hard to gauge which people were doing appropriate amounts of work. Some of you wrote very poor feedback, and that will be reflected in your grade if you wrote particularly bad feedback. But on top of that, it's just kind of hard to tell who is contributing because some people had bad Trello boards, some people had bad feedback, and so we're going to do it more objectively. Basically, each person is going to rate how each of their peers contributed to the project. We're going to use that as a basis point and compare that to your commits and compare that to your Trello boards and basically figure out if there are warning signs or not. We also have a group assignment where basically you have screenshots of tests and coverage and stuff like that. And only one person per group has to do that. The other people don't even have to open that up. You'll all get full credit for doing that. On that note, we're actually going to do those right now. So go ahead and get that started. I'm going to give you 15 minutes. So we're going to hop back together at around 12:50. Leave any questions you have for me here about Project 2. So go ahead and do that. Oh yeah, quick thing about that. For the group assignment, one of the questions is like screenshot your Trello board. it doesn't matter. You don't have to like submit each individual task. We don't care. We'll just check your Trello board if we need to. What we're checking for is making sure that each of you has names associated generally with each of the tasks in there. So like we're not using that as a source of truth, like your screenshot. We're just making sure that you are actually putting your names in there. So any screenshot where you can prove that all of your like most of your tasks in there have names, that's fine. We'll give you the points for it, but just make sure that your Trello boards have names associated with each task. Cool. Let's come back together at 12:52 to continue lecture. Again, if you have other questions, feel free to share them. I'm also not going to assign you breakout rooms because that's going to take like 10 minutes to do. So just go ahead and use your Slack or Discord groups to coordinate who's doing the group submission. Again, only one group submission per group, but each person has to do their individual feedback. Any questions about project 3 in general? Oops. Cool. Also good news. 8 minutes ago, my Amazon account was reactivated. I had to like contact someone internally, which is kind of frustrating. But the Amazon account was reactivated, which means that theoretically your Cloud9 problems should be going away now. So double check your Cloud9s now. They should theoretically be okay. So like, well, just don't, just try it again and then let me know if you're still having like issues where your terminal is not working or something like that. How is presenting your project going to work? I will give you a like sample template or a sample presentation of what your project presentation will look like. It's going to be a live demo. You can't record it or anything like that. But I will show you like a sample of what it might look like. Does that sound good, Bishoy? So you can like come up with a script, you can come up with whatever you want, but it does have to be live. You can't just like record it or anything like that. And I'll share that with you like sometime next week. Bishoy, could you message me on Slack with that? That would be really helpful for me just so that I remember that that's on my to-do list. Cool. Now let's talk about class diagrams. So we already talked about specifications modeling and using unified modeling language, but I never really went over what UML is. So UML is basically a model of how different people use your app. So you might have different people like clients, you might have an administrator, and they have different ways to interface with your app. So administrators should be able to delete your user, which closes an account, or the client can directly close your account too. So UML has a specific type of something called a class diagram. So this is a structural diagram again, and it shows the system, it describes the system by showing its classes. So this includes attributes, operations, and relationships among the different objects, and this is going to be done in a technical way. So here's an example. So you've probably seen something similar to this sometime in your life, right? So you've probably seen this as a representation of the different classes, of the different methods within those classes, stuff like that. So here we see like customers, orders, order details, items, stuff like that, and all of them have interdependencies. A class diagram is going to be one of those boxes. So if we go back up here, each of these is different class diagrams. How many class diagrams do we see here? Wait, actually, I might be wrong on that. I think this whole thing is one class diagram. I don't actually remember. I don't really care. It doesn't matter. But anyway, classes are represented in a class diagram using this format, 3 different compartments inside of one box. The uppermost box contains the class name, the center box contains the variables, and then whatever types they are. And then the bottom box is going to contain all the methods. So let's go over a class diagram for chatbot.py in project 2. And now you'll see why I'm thankful for my iPad, because I can draw again, which is very nice. Cool. Let's go over what a class diagram is going to look like. So Again, we have 3 different components. What goes in the top component for our chatbot.py file? Yep. So this is just going to be the name. So this is just going to say chatbot. So this is just the name of the class of the class. What about the second one? What goes in our second compartment, and what are some examples of those things? Not parameters. They're going to be your class variables, or yeah, pretty much your class variables. And what are those class variables? Like, what might be some class variables inside of your chatbot? Okay, name. If let's say your name had a it was like a variable, sure. So bot name. What else? Let's do like 2 or 3 more. Message count. Okay. Functions do not go here. So message count, and let's say this is a list of strings. Okay. What else? The message, yeah. Message itself. So this might be a string too. Cool. And then what is this last one? This is going to be the functions. So what functions might we have here? Help. Okay. Okay, sure. Help about, oops, I didn't mean to put these minuses here. About, one for each of the commands. Okay, API calls. Okay, get whatever. I'm just gonna make one up. Get tweet, translate. Sure. That all sounds good to me. Cool. Good job. We also have access modifiers inside of here. We use different symbols to represent the access modifiers assigned to them. So this is how you represent it in UML. Public methods or variables have a plus, privates have a minus, and protecteds have a hashtag. The name, message count, and message. For each of these, should the name be public or private? Actually, before we jump into that, what is a public method? Who can access a public method? Like what callers can access? Yeah, pretty much accessible by entire code. So everybody. What about private? Can be called from outer class, sure. Outer slash self class. And what about protected? And these are CS 100 fundamentals, so we should make sure that we understand these things. And I'm assuming we all know this at some point, but what is protected? Thoughts on that one? I'll give you a hint. Protected is in between public and private. View only from the outside class, not quite. Yeah, it's basically self and children. It's going to be self and children can see the protected stuff. Private is going to be only itself, and public is everybody can see it. Yep. Okay, so with those definitions, what should name, message count, and message be? Should those be public, private, stuff like that? Any thoughts on those? Public. Okay. Saksham thinks public. Anybody else think anything differently? Message count could be could be private. Okay. Okay. So one thing I want to talk about is a lot of people tend to go public for everything. That is bad design because would you ever have a situation where someone who isn't your chatbot wants to modify the name of the chatbot? Like, is there any world where you need to modify the name of your chatbot outside of the chatbot? Probably not. That usually breaks down because that basically means these are all global variables. To prevent that, what we're going to do is do private for everything. By default, we're going to say everything is private. And then if you need it to be public, you add a method that says get message and set message. So that way you don't have a public variable. You have that internally, and as you need to, you can get or set those messages. Um, what about all these API calls? What about the API call like translate or get tweet? And then what about help and about? Should those be public or private? Private. Why should those be public? Well, if those are private, I would make them helper methods and be private. Okay, sure. That actually makes sense to me. Yeah, if we make these all private methods and then we just have one thing out here that says parse message, and that is our public interface, then that totally works for me. Yep. And I think that's the smart way to do it. We should make all of these private and then just say get message and parse message. And those are our public methods. Absolutely. That makes a lot of sense to me. Good job. We can also take a look at different relationships. When should you use an interface to describe a class? What do you mean? An interface doesn't describe a class. An interface is a type of, it's a type of object, basically. Um, Interfaces in general are going to be used whenever you have different types of something. So this is a bit of a tangent, but I'm okay with that. So here's an example. Let's say you have an interface vehicle. So an interface is basically a definition of what a vehicle has. So vehicles, what can you do with a vehicle? You can say you have a method drive, you have some variable cost, and then you have some variable, you have some method build maybe, so that you can actually create the vehicle. Now, the thing is, if you go to a store, you can't just buy a vehicle. Imagine if you walked into a dealer and you were like, I would like to purchase one vehicle, please. They'd be like, that doesn't make any sense. Tell us what vehicle you want. So you can't just have a vehicle, you have to have an implementation of a vehicle. So you might say something like class car is an implementation, so implements vehicle. And then this basically says that you have to define all of these different things. So here you would say something like at override, and then you have public void drive. So I'm doing this in Java because that's the language I'm most familiar with. But you have something like public void drive, and then you actually do what you want with your drive. Now, the definition of drive might be different between a car versus, I don't know, a truck, for example. So this is what an interface provides. It's a template of classes, and you have to implement all of these, but all of these are important things for a vehicle. You have to be able to drive it, you have to have a cost for it, and you have to be able to build it. Otherwise, a vehicle can't exist. You can't have a car that doesn't have one of those things. You can't have a truck without one of those things. But you can't just have a vehicle either. You need to be able to say what type of vehicle, and the type of vehicle that we have is going to have separate implementations for all of these. Interfaces are great to use. Interfaces are used all over the place and they're fantastic. They're a good sign of good architecture and a good sign that you know what you're doing with your code and it's scalable. Abstract classes are a little bit different. I'm not going to teach you what an abstract class is because you should never use an abstract class. That's just pretty much a rule. Just don't use an abstract class. Use interfaces instead. So this is what an interface is. Hopefully that makes sense. Did that answer your question, Ronak? Cool. Yeah. So interfaces are good. Keep using things like this, which basically say, hey, this is the template for actual classes that I'll create. And it's going to scale because you might have a similar thing like class truck implements vehicle. And then it will implement drive and all of those too. One thing to keep in mind is I don't know if Python has interfaces. I'm actually not sure on that. But in general, Python isn't super object-oriented to begin with. You can do object-oriented Python, but it's not like the default or anything like that. That's just one thing to keep in mind. In languages like Java and C++, you'll see this a lot more. All right, let's talk about the class diagram relationships. So not only do you have these different classes, but you also have relationships between them. You have association, inheritance, implementation, dependency, aggregation, and composition. So here's an example of a relationship. So a spreadsheet obviously contains cells. You cannot have a spreadsheet without cells. A cell must contain an expression and a value, or sorry, it can contain an expression and a value, which make up cells. However, one thing to keep in mind is a spreadsheet has to have cells. You cannot have a spreadsheet that doesn't have cells. So an association is basically a relationship. It's a one-way relationship like everything else here, and these are going to be for sure that if we have A goes to B, that means that A cannot exist without B. B is a strict dependency upon A. We also have aggregations. Aggregations are slightly different, where it's basically saying a class plays a more important part than some other part of it. They're not necessarily dependent on each other, but they play pretty important roles. So to give you an example of this, we have an order and you have a menu item. Now you can satisfy an order without a menu item. You can order off the menu, you can just ask for water or something like that. You don't necessarily have to have a menu item to make an order, but it's a pretty important part. Most of your orders are going to go off the menu items. Similarly, you have a human who has different attributes, and most humans have eyes. It's not a requirement of a human to have eyes, but most humans have eyes. So you might have these different things. You might have an eye, which is a class, and that is an aggregate relationship of a human. Any questions about aggregate versus association? Again, you're not going to be like necessarily tested on this stuff. It's not like I'm going to be asking you for these definitions. I don't really care about that. But I just wanted to ask about that. Or I just wanted to give you a slight, I just wanted to give you like a slight intro to that stuff. Cool. Let's keep going then. We also have multiplicity. I'm just going to skip multiplicity for the sake of time. You can look back at these notes later, but you can basically see these different multiplicative relationships, which basically say how many of each object are corresponding to other objects. And then you also have inheritance. This goes back to Ronek's interface question. Basically, bank account is an interface here. And then these are implementations. So you can't just go to a bank and say, I want to open a bank account. They're not going to know what to do with that. But you can go to a bank and say, I want to open a checking account, and then they'll know what to do. They'll know exactly what that means. So an interface is a definition or a template of a bank account, but then you have checking accounts and savings accounts, which are actual implementations of that. Any questions about anything that we just went over? Oh, I'm getting a little laggy. Any questions about class diagrams overall and why we use these? Cool. I'm gonna keep going then. All right, so next we're gonna be talking about design principles. Oh my God, so much lag. Um, is my voice cutting out, or can you hear me clearly and just the lag is on the screen sharing? Okay, cool. Good to know. If the lag is only on the screen sharing, that's not as big of a deal. Cool. So design principles are what we're gonna talk about next. Um, so software design is a process to transform user and system requirements into some suitable form. And this will help the programmer in construction and implementation. So we have different ways to do this. We start with our requirements engineering. So again, we talked about our requirements engineering process. That was the non-technical stuff. Software design is basically translating the requirement specification into actual technical specs. So we're going to start by doing an architectural design, which leads to system architecture. Then from there, we go and do our abstract specifications. And then for each of these steps from there, we have a design and a specification. So we have our abstract specification, then interface design, component design, data structure design, and algorithm design. And each of those has the design component and then the specification component. Today, we're going to be talking about the architectural design. So this is an early stage of the system's design process, and it represents the link between requirements and design processes. Where do we finish requirements and start the design? Well, we can often do that in parallel. We can basically say that engineers will start doing the design stuff, and then PMs or someone else might do the requirement stuff, and you might do those in parallel. Obviously, you can't do the entire implementation until you figured out the requirements, but you can start doing the boilerplate and you can start doing some of the templating before you actually finish the design process. Now, one more thing here. If we go back up to this flowchart, architectural design, like I said, is going to be the rest of the class. We're going to be talking about how to plan and architect software pretty well. If we look at data structures and algorithms, we don't really cover that too much in this class. Most of this is CS435, but some of this is also just the data structures that you work with in this class. So for example, this could be something like chatbot.py. That is a data structure. So we are covering a bit of that, and we've already done that stuff. In terms of the component design, we kind of did parts of this in our proposal, but not too much of it. We did some user stories and we did some acceptance criteria. I would say acceptance criteria get close to this. And actually same with interface design. The abstract specification, we're not going to do too much of in this class, but this is going to be where you actually think about how different components fit together. Now, we're not going to cover too much of that. We'll cover a little bit of it, but we're not going to have too much time to cover that. If I had an extra month in this class, we probably would have covered a little bit more about the abstract specification style. But for the next like 3 to 4 lectures, whatever we have left for the semester, we're probably going to cover architectural design and architectural choices. So as a definition, we have these different components. We start with the architectural design where we identify the subsystems. We have the abstract specifications next where we specify what these subsystems should be. We then design the interfaces, which basically say, let's take our subsystems, we define how they interface with each other. Then we move into the components where we decompose them into separate components. Then we actually do the implementation using our data structures and algorithms. So as part of number one, we have these different things that we want to think about. We have our system structuring. So basically our system is going to be decomposed into several different subsystems, and we're going to figure out how they communicate with each other, how they're going to identify which components talk to each other and how they do that. Control modeling is where we actually take the models and we establish the models of how they, we establish the relationship between these different components. And then modular decomposition is basically you take each of the subsystems and break them down into modules or methods. Now, here's where the things get interesting. So that's on the high level what design looks like. But now we're going to go into the weeds and actually talk about what these different principles look like. This is my favorite stuff to talk about in the entire class. So these are how you elevate your software engineering from it works into it works well. So there's four different design principles that I want to talk about. There's abstraction, modularity or federation of logic, information hiding, and limiting complexity. You've probably heard me talk about these a lot, but I'm actually naming them here and we're going to break them out into separate work things. So the first one is abstraction. So abstraction basically means that the interface of a component should be independent of its implementation. So the interface is the user's view of the component, and the implementation is the developer's view. So basically, the importance of this is you don't need to understand how a component works in order to use the component. Can anybody think of any examples of what this might look like where the front end might not necessarily match up with what you're doing on the back end, like in terms of like the naming and all that stuff? We do that with chatbot with using process text. Um, let's see. Yeah, yeah. Okay, I get it. So basically in your chatbot, you basically have like the UI is basically going to have a certain way of interacting with it. You basically have you send a message and then that message is either picked up by the chatbot bot or it's not. Now the user doesn't necessarily understand how it works. They're just expecting that it does work. If I put an exclamation exclamation, it should trigger the chatbot. If I don't, it should just be a regular method or it should just be a regular message. So on the back end, you're doing a lot of stuff. You're processing the text, you're breaking it into the chatbot, you're doing a whole bunch of things. But the user doesn't necessarily know or care what's actually going on. Another way to think about how this is going, another way to think about how we might do this is making sure that you have nicely named methods so that other developers can actually just use your methods without necessarily reading through all the logic. So let's come up with two different examples here. Oh, my screen is frozen. My bad. So let's come up with two different examples here. So we have, oh my God, it's very laggy. So let's say that you have a function that takes in two variables, A and B, which are strings, and then it does something inside of it. Now the problem here is that if someone wants to use your function, they have to read through your entire function and figure out what's going on. But on the other hand, if we have a function, the same method, but we call it verify password, and it takes in a username and a password, now suddenly we're able to figure out exactly what use verify password does without necessarily reading through that code. That's a good example of abstracting your logic away, just so that you don't necessarily force someone to read through your logic unless they really have to for like figuring out a bug or something like that. Our second design principle is modularity. So modularity means that we should build systems using cohesive, loosely coupled components. Loosely coupled means that component changes are unlikely to affect other components. Object-oriented systems are generally loosely coupled because there aren't shared states and objects communicate using message passing, not directly with one another. Tight coupling means that you are likely to affect other components if one changes. Shared variables might lead to tight coupling, for example. Why would we want to use loose coupling instead of tight coupling? Why is that like a thing that I'm specifically saying we should be doing? Loose coupling allows for interchangeability and reuse of code. Excellent. Awesome. A very, very concise answer. Basically, yeah, you want to be able to change things out on the fly and reuse lots of code as you feel fit. Great answer. It sounds like a textbook answer, basically. That is pretty much what we're looking for. We want to make sure that we can easily reuse code and we can easily interchange different components. Um, Very confusing that my screen keeps freezing. So maybe my internet is not back up yet, sadly. Okay, cool. Okay. And then we also want to talk about modularity, which deals with the ability with the property of cohesion. So cohesion is a measure of how well a component fits together. So a component should basically implement a single logical entity or task. It shouldn't do multiple things. One method should do one thing. One class should do one thing. This is known as the single responsibility rule. And in general, it's hard to measure, but here's some measurements on how like you might build cohesive code. So the different types you have here are coincidental. Coincidental means you don't have any cohesion. You're just randomly putting things together. There's no rhyme or reason. This is what most of us did in project one. You had one chatbot.py or app.py, and it just handled all the logic without really knowing why you're putting things in certain places. You also have logical association, where basically components that have different functions are grouped together, or similar functions are grouped together. You have temporal, which basically means that based on the time of different component activation, you'll basically say, hey, we're doing all of these things at the same time, put these together. Now, these aren't great ways to build cohesion. These aren't like the ideal ways in which you would actually put functions together. So these are all weak cohesion types. But as we move up the spectrum, we have communicational cohesion, which basically means you're saying that all of the things that deal with the shared input or produce the same output are grouped together. You have sequential cohesion, which basically means that you have one thing leading to another, leading to another. The input of one is the output, or sorry, the output of one is the input to another. And lastly, you have functional cohesion, which is the ideal and the strongest way. Each part of a component is necessary for the execution of a single main function. So let's say, for example, we have main.py in our project one. And then main.py calls into tweet.py. It makes a call into here. And then it also makes a call into spoonacular.py. Let's say that instead of calling a tweet, like we call into this using some method, instead of calling a tweet, we actually want to change our design and we want to call Facebook, like we want to have a Facebook post instead. Um, how many lines of code, or like where do we actually have to change our code to make it use Facebook instead of Twitter here? Main and then a new Facebook file. Yeah, exactly. So all we have to do is break this connection. I'll do it in red so that you can see my changes. Okay, so we're just going to break this connection. Instead, we're going to make a new connection to facebook.py, basically. And then all we have to do is change out one line of code in main.py. We just have to be like, we don't need twitter.py anymore. We break that connection and we build a new one into facebook.py. And that is functional cohesion. None of it, like main.py isn't going to work unless you have its dependencies, but it's built out and modularized in such a way that you don't necessarily have to change everything out. This is why federation of logic is important, because making a small design decision, like using a Facebook post instead of a tweet, is really easy to implement here. All you have to do is break this connection and make a new connection. Cool. Our last design pattern is, or design principle is information hiding. So what this means is, again, all information should be private unless it's specifically declared otherwise. Each component should have some interface, which is how the world sees it. Anything beyond that interface should be hidden. Here's a pop quiz that I'm hoping you've learned in other classes, but what is this interface called? The component, the interface that the world sees externally. What is that interface called? Okay, it's not, when we say how the world sees it, it doesn't necessarily mean like the actual UI. It means like, let's say you have chatbot.py and you have like some public methods inside of there. What are those public methods in chatbot.py called? Any thoughts on that? Yes, an API. Exactly. So an API is a collection basically of publicly accessible information within an object. So this interface is basically how the world sees our class, and that is called an API. Anything outside your API should be private, and you should have things in your API on purpose, not just because it's easier that way or something like that. So make sure that you don't have, make sure that all variables and operations are private. Start with them all being private, and then change them up to be protected or public as you need them to be. Globals are almost always bad to use. It usually means you're doing something wrong with your code. And we'll talk about how you can avoid globals. We already talked about how you can do that with MVC, but we'll also talk about how you can avoid that in a little bit later on in this lecture. There's also more design patterns. You have these non-functional things like changeability, interop, efficiency, reliability, testability, reusability, understandability, and adaptability. We're not going to dive deep into these, but it basically means make sure that your code is scalable, make sure you can reuse things, make sure you can prove that it works, make sure you can reuse different components, make sure it's reliable, and make sure it's efficient. If you can't prove that with each of your components, then you're probably doing something wrong. So this all sounds great. We have a lot of design principles, but how do we actually incorporate these design principles when we're designing software? And this is where design patterns come in. Design patterns are one of my favorite things to talk about, and it's one of my favorite topics in software engineering. So now we're going to talk about design patterns. But before I do that, do you have any questions about any of those design principles? Keep in mind again that this is some of the most important stuff that we're covering in the class. It's really important that you understand how to use these different things. You might not be tested on that necessarily, but these are the things that are going to make you actually successful software engineers. Cool. So design patterns are templates for solving problems to commonly occurring problems in software design. Give me one quick second. I gotta do something. I'll be back in like probably a minute. Oh, actually, yeah, I'm just gonna, so I just have to take attendance for today. So I'll just go ahead and screenshot right now. Cool. Awesome. So anyway, so design patterns are templates which we use to solve commonly occurring problems in software design. So design patterns are basically our answers to questions that commonly arise when we're using object-oriented programming. So these are questions like, how can I do this? And they were founded by a gang of four to basically make it easier for us to follow a template that helps us make it scalable, make it modular, make it abstract, like all those things that we just talked about. It's basically ways that we can design our software so that we can do this more easily. We have different categories of design patterns. We have creational patterns where you make objects. You have structural patterns where you control the structure, maybe affect the API or the data structure layout. Then you have behavioral things where different objects, you control how objects behave with other objects. So this first category is creational. So we're going to see 5 different types of design patterns here. We see singleton, or we have way more than 5, but here's 5 that I pointed out. Singleton, prototype, builder, abstract factory, and factory method. For each of these categories, I'm going to show you the actual ones that I use or have seen at work, and the ones that I've never seen. It doesn't mean that I necessarily won't see them, but I just personally haven't seen them. So in this category, I have never seen an abstract factory. I have no idea what that is. I learned it sophomore year of college, and that was the last time I ever learned about that. I have, however, seen factory methods, singletons, prototypes, and builders. Quick aside, builders are my favorite design pattern. I try to make a lot of people use builders at work. And oh yeah, the other one that is creational here, or no, sorry, ignore that. Builders are my favorite design pattern. I love using builders. We're going to talk a little bit more about builders later on. But before we do that, let's talk about singletons. So let's take this scenario. You just finished your chat app and it looks amazing. Your chat app is in a separate class, and every time a client makes a call to your server, your chat app instantiates a new chatbot object. Is there anything wrong with this? Is there anything that could be problematic about that? It would probably be better to have a single instance queried repeatedly. Sure, but why? We'll get to why single instance is better, but what's problematic about having multiple? And yeah, Joseph mentioned a lot of chatbots are made, but why is that a problem? Takes up unnecessary time to make and space to create, sure. Um, I would say there's a bigger problem than that, but that is a valid concern, yes. Time and space. What else? You can't make multiple instances? Well, we are making multiple instances. But what's the problem with making multiple instances? Yes, exactly. Memory used up every time, and if it's not released, that's a memory leak. So yes, this could result in possible hard to debug memory leaks. I can't spell, I just spelled memory lacks, but yes. Um, Memory leaks can be a big problem here. If you do something like this could be really problematic in terms of having these memory leaks. So one way to prevent this from happening is using a singleton. A singleton is a creational design pattern that helps you ensure that the class only has one instance while providing a global access point to that one instance. So the way this works in code is basically a singleton has an instance, which is a singleton, and then it has a constructor that is that it just has a constructor called singleton. And then you have get instance, which is a method that returns a singleton. As a recap, what do these minuses and plus means? What do these minuses and pluses mean? Like there's a minus here. What does that minus mean? Yep. So these are private. Both of these are private, like we talked about. But this is really interesting, right? You have a private constructor. That's not something you often see. You usually see public constructors. But in this case, the only public thing is our get instance public method. Now, the way that this works is the singleton class declares get instance, and then that get instance just returns the same instance of its own class. Now, this is really interesting. The way get instance works is it looks something like this. If instance equals null, make a new instance. Otherwise, just return the new instance. So you don't actually have to expose the constructor, and the client doesn't care whether you're making a new one or an old one. It just says use the existing one that I already have. And this is just going to be controlled globally for the entire application. Singletons are used all over the place. They're one of the most common design patterns that I've seen used. So I really, really recommend singletons. I think that they're very useful design patterns overall. Um, let's talk about, oh yeah. So what are some of the different examples you might have of singletons? So just to be really clear about singletons, you don't have a singleton per user. You have one singleton for every user on the entire application. So it's not like one per user, it's for, no matter if you have one user or 1 billion, you still have the same amount, you still have exactly one of this class. What is an example of a singleton in the context of, for example, Facebook? Like, in terms of Facebook, what is there only one of for the entirety of Facebook? Any thoughts? So a login page, that's not quite right because if we have a login, like Mohammed's gonna see a login page and I'm gonna see a login page, right? So that's per user. If you have a billion users, you have a billion login pages. You don't have one login page that's shared for every single person or anything like that. What what is the one thing? Okay, think about your applications, for example. In your chatbot, what is the one thing that is shared for all users? No matter how many users you have, there's only one thing. What is that? And as an example, you can't really have front end singletons. It doesn't make any sense because each person has their own front end. So it's not something in the front end. So we can narrow it down to something in the back end. What in the backend is shared amongst all users? Database instances. Yeah, I did mention that. What do you mean? I don't think I mentioned that. Um, but yes, databases are definitely shared. Databases are a good example of singletons. Basically, you only have one database for Facebook. Of course, one thing to note is with Facebook, like a database isn't quite only having one of them. Like you'll have more than one database, but that's just because you want replication and duplication so that if that database gets corrupted, like Facebook doesn't fail as a company or something like that. You said that Facebook has one database for Facebook as an example. Oh, okay. I don't remember saying that, but I probably did. I believe you. Yeah, so databases count. One thing I would say is I don't like it definitely is a singleton, but I don't personally think of databases that way just because databases are like they're not really code. They're their own separate technology. The other one I have is let's say that Joe and I are friends on Facebook. And then let's say Mohammed and let's see, Mitchell are friends on Facebook. But we're not friends with each other. Joe and Mitchell, or sorry, Joe and Mohammed, Joe and Suresh, Mohammed and Mitchell are friends here. Um, we're just gonna have one of this thing, this object, right? You're not gonna have one per person. You're not gonna have one per user. You're gonna have one global state of this entire object. What do we call this object in the context of Facebook? Anybody know the name of that? It's a friend request, sure. But like the object that actually keeps track of what all these friend requests look like, do we know what that is called? What does this look like in the context of 435 data structures? What does this object look like? Yes, it's a graph. So this is a graph, and we just call it a social graph or a friend graph in the context of Facebook. So a singleton in the context of Facebook is the social graph. You're not going to have one social graph per user because that would be crazy. You're going to have one shared social graph for the entirety of Facebook, and every user is going to modify that social graph when they send friend requests. Make sense? You also have other examples like print spoolers, file systems, window managers, databases, stuff like that. Our second category of design patterns is called structural design patterns. So we've already gone over MVC in this class. MVC is a structural design pattern. Other examples include adapters, facades, bridges, all these things. I want to say again, I have never heard of a facade, a bridge, composite, flyweight. I've sort of used proxies. I've sort of used decorators. We use MVC all the time, obviously, like we talked about. And then I've used adapters for iOS code. So the two that you really see being used for structural is MVC, which is by far the most common one. And then you'll see adapter as well. Decorator and proxy, sometimes I've literally never heard of the other four though. But we're gonna go over decorator anyway. So decorator, let's take this scenario. Your group has finished your chat app. It looks amazing. Your chatbot is in a separate class and it handles all the logic of your chatbot. But your entire group, there's 4 of you, and you're all working on different bot commands at the same time. Is there anything wrong with this? Can we think of any problems with this logic or the way that this is structured? Yeah, merge conflicts. Merge conflicts suck. You've probably noticed that merge conflicts suck. And if you do something like this, you'll have merge conflicts 3 times a day. And that is a lot of time that you're spending working on your merge conflicts. So let's introduce the decorator pattern. One thing I want to say is I don't love the decorator pattern personally. I think there is a better way to do this called the builder. And I'll talk about what the difference there looks like. So the decorator pattern is a structural design pattern that lets you federate logic more easily by having one central class that is then extended upon by having multiple different additional classes or features. So let's say you have an interface coffee that has cost and ingredients. If you have a simple coffee, which just, it costs $1 and the only ingredient is coffee. Now, you can implement an abstract class, basically, that implements coffee. Again, abstract classes are bad. Never do abstract classes, which is why I don't love the idea of decorators. But you could theoretically probably do this using interfaces too. I just don't remember how to do that, and I didn't really try that hard. But in an abstract class, you basically have coffee decorator, and then you basically say you get the cost of it, and you add, or it has the same things basically. Get cost gets the decorated coffee, and the ingredients the same way. Now, an example is you might have a class that's called with milk. With milk takes the super class and adds 50 cents. It also takes the ingredients list and adds milk to it. With sprinkles does the same thing. It adds 20 cents to the cost and adds sprinkles to the ingredients. Now, the way that this will work is you'll see something like this. You do inside of print info, you have this information. And basically you say you make a simple coffee and print the information. So it's $1 and it has coffee. Now you reinstantiate C as with milk. And then you print the info and it adds 50 cents here and it adds the milk. And then with sprinkles, it just adds sprinkles instead of remaking it, which adds 20 cents here and adds sprinkles. Now, I really dislike this. The reason I dislike this is you're instantiating C here. Why would instantiating C depend on the old value of C? That doesn't make any sense to me. That feels so wrong to me, and it feels like an anti-pattern. So the way that you can do this in a slightly better way, the way that I prefer, is you do something like this. Coffee equals, or coffee C equals coffee builder. So this is the builder pattern, and this is my favorite way to do it. So you say coffee builder, and then you can basically add the components as you want. So you can basically say dot add milk. And then if you want to, you can do dot add sprinkles. So you build it piece by piece, and then you say dot build, which actually makes the coffee. I think this is way cleaner. I don't know about you, but I like the idea of basically being like, hey, if you want coffee in it, or if you want milk in your coffee, you add it. If you want sprinkles, you add it. You don't necessarily remake a new you don't make a new object that's called with milk or with sprinkles. You just add it as you want to. Now, one thing to keep in mind is what is the return value of add milk? Can anybody see what the return value we have here is? You should be able to see that based on the context. What are we doing with the return value? So it's not a not quite. If this returned void, then you'd have null.add sprinkles, and that would just throw an error. That would be bad. Same with if you had coffee here, then coffee.add sprinkles would be like, hey, I don't know what that method is. That doesn't make sense. So it's not coffee and it's not void. It's actually coffee builder. So this is going to return coffee builder. So this returns coffee builder. So one thing to keep in mind is at the end of each of these methods, you're going to return self, basically. You have to return itself so that you can keep building on it as you go. And then what is this actual builder going to end up returning? Now is your chance, Robert. This is going to return a coffee object. So this returns coffee, but these return self. Add milk and add sprinkles are going to return self so that you can keep building on top of that. Cool. So that was the decorator, or that was the builder and decorator patterns. I strongly prefer builder. I would absolutely stay away from decorator as much as you can. Let's talk about behavioral now. So inside of behavioral, we have these 8 things. I've never heard of chain of responsibility, iterator, state, observer. I've never heard of any of these, but I've heard of iterator, state, and observer. So those are the 3 that I've heard of. We also have our state machines here, and that's the one that we're going to be talking about. So you finish your chat app, it looks amazing, but every time every time a user takes an action, use sockets to communicate what action has happened. This is what we did in this class. The action that the server takes depends on what the event name is. Now the problem here is your event name has to be relayed in 2 different places. You have the server side things and the client side things. Now the problem is whenever you do that, you're going to have to add code on both sides, and there could be silent errors. Like if you add a new event name on the client, but you don't add it on the server, you're not going to see an error message. It's just going to disappear into the void, and you're just going to have no idea why it's not working. One way to do this and avoid it is by using one event name. Use the same event name for every single socket that you have. And then inside of that event name, you actually pass in the type of event as a parameter. You basically say, hey, this was a change in state. So state machines map an input to an action, which then updates the state of the system. Based on the state, a message may or may not be delivered. So let's say that, for example, you have logged out. So this is the user state, which is in a circle. And then let's say that you get a new event with logged in, user logged in. So if we say user logged in, what should the new state be? I'm just going to tell you. It's going to be logged in. Now, if you're logged in and somehow you get user logged in again, oh, what the heck just happened? Okay. If I'm here and then I get user logged in again, it should just keep me logged in. So the reason you use state machines in industry instead of using like these different sockets to communicate is the state machine lets you figure out what your states are at any given point, and you get to debug specifically, hey, if I'm in logged out and then I get a logged out message, how in the world did that happen? Like I should be able to debug that much more easily because I can be like, if I'm in logged out and someone gave me a logged out message, I can replicate that very easily and figure out exactly what the state was and the event that changed the state. Oh, sorry, this should be user logged out. Cool. So that's the advantage of state machines, and that's why I recommend using state machines there. Next time in CS 490, so don't forget, you don't have class tomorrow. Tomorrow is a Friday schedule, so make sure you go to your Friday classes. Same with office hours. Office hours are going to be on the Friday schedule, not the Wednesday schedule. Finish your group and individual submissions for Project 3 MVP. That's due tomorrow. It's very important that you do that. We can't grade your MVPs until that is done. Next Tuesday, we're going to be talking about how to debug your code and how to tweak your resumes. I have plenty of volunteers from this class, so tell your friends in the other classes that they should volunteer their resumes, and we will go over them in class. Also, enjoy your virtual Thanksgiving. I know that it's not ideal, but I really hope you have a great time with your families. and you have a much needed break at this point. I'll see you back on Tuesday, but before that, please make sure you do your group and individual submissions. It is worth points, and we can't really grade your project 3 unless we have that from you. Great. See you next Tuesday. I'll talk to you later.